All right, guys. So we're gonna do measure. Oh no, let me zoom. Oh my gosh. ¿Qué pasó ahí? Give me 1 second. So we're doing measure. Why is it so big like that? All right. Measure of spread. And now you can't see anything I'm writing for some reason. It came out sort of. You're recording, right? Yes, I am. I'm recording. Okay, so we done just basic graphing and things like that, stem and leaf. And we've done measure of center. So we done basically mean, median, mode. Now we're going to do measure of spread. So the spread is how far data is from each other. The first one we're going to talk about is range, and there's not much to talk about range. It's just take your max and you subtract the min. Obviously, the biggest number minus the smallest number, that's your range. Okay? There's nothing to talk about there. It gives you an idea of the spread of the data. Not too useful, but it's good. It's like, you know, biggest to smallest, how far away are they from each other? Now, the next type of measure spread is called the interquartile range. And that we just abbreviated. I don't know if this book likes to abbreviate that way, but usually it's IQR. And it's quartile 3 minus quartile 1. And then you guys don't really know what quartile is. Maybe some of you do. So that's what interquartile range is. It actually means, it means the range of the middle 50% of the data. Okay.
So middle 50%, middle, but the middle of the 50%, the 50%.
Middle 50% of the data. Okay, so it's okay. So can you imagine? Okay, here's the data. I'm gonna divide it into 4 equal parts. All right, let's just say the range is from here to here.
Right.
The interquartile range is a range from here to here, where most of the action is taking place. The middle 50.
Okay.
Got it?
Yeah.
Yay. You guys saw my abs, right?
You know you're recording, right?
Oh my gosh. Like on my shirt.
Yeah, like this sounds really bad.
Mathematics is lovely.
Yeah.
Sadly, it's beautiful. Okay, anybody have a question? Well, your question should be, how do you do the quartiles, right? And so that's what I'm going to spend the next few minutes talking to you about, how to do the quartiles.
Is it going to be in the test too, or is it just?
No, this is not yet. You're just going to have to worry about what I posted for your test. So we're going to do quartiles together right now. And to be able to do the interquartile range, you need to figure out how to do quartiles. Okay, so we have some numbers there. Okay, the first thing you need to do to find quartiles is you got to put the numbers in order. Are those numbers in order? That's correct. It's negative. So let's go ahead and 7, 8, 9, 11, 12, and 13. Agreed? Now, how many numbers do we have there? 6. So that's even, right? So we have 6 numbers. It's even. So the first step is find the median. Do you know how to find your median for 6 numbers?
Yeah.
What's 6 divided by 2? What is it? Well, I don't know, but what's 6 divided by 2? So you take the third number and the fourth number, add those two and divide by Yes.
I can say it.
I know, but I'm just, okay. No, I'm trying to make you stronger. All right, so the median here is 10. Now, guess what? The median is also called your second quartile. It's Q2. Q's of 2. Second quartile. And now, guess what? The data has been split into a lower half and an upper half. You see that? And so we have 3 numbers in the lower half and 3 numbers in the upper half. Can you find the median of that? What's the median for the first one?
7.5.
No, because if it's odd, you just pick the middle one.
Oh.
So this is your first quartile. And what's the median for the upper half? 12. This is your third quartile. So now can you do your interquartile range? Your interquartile range is quartile 3 minus quartile 1. That's going to be 12 minus 8, which is equal to? Ta-da! Is that difficult? No. So let's try another one. I want you to work on this on your own. I'll pause the video. 7, 8, 22, 20, 15, 18, 19, 13, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 numbers there. Could you put them in order first? Okay, so let me go ahead and just separate the 2 problems. Okay. All right, and then we pause it. So let me go ahead and pause the recording. Okay, so I put the numbers in order there. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So that's odd. The middle number, what's 9 numbers plus 1? That's 10 numbers divided by 2. It should be the 5th number. 1, 2, 3, 4. And as you can see, I know, but what I'm trying to say is I can make this so much interesting. I might say to you, hey, there's 73 numbers. If they're in order, which but what's 73 plus 1? 74. And what's 74 divided by 2? Something, right? Well, whatever something that is, which it should be 37.
It is 37.
The 37th number would be your middle number.
But you still need to count either or.
No, but look how easy it is. Look, it's very simple. It's even number. If there's an even amount of numbers and we put it in order, and it's all right, so let's pick an even number.
26.
Okay, what's 26 divided by 2? 13 and 14.
Yes.
Add them together.
And then you got to
Divide by
count to 13 and then get 13 and 14.
I know, but I'm not asking you. I'm saying which numbers would be it, and then you could be able to figure it out, and you don't need to like count and cross things out. Okay, so notice this here, that we now have the lower half and the upper half. How many numbers do we have in the lower half?
4.
So that's even. 4 divided by 2 is 2. So take the second one and the third one.
8 and 11. That's 9.5.
8 plus 11 divided by 2 is 9.5. This is your first quartile. And what about 19 and 20? Add those two. Okay, perfect. 19.5. And this one here
9.5 minus 9.5.
is your third quartile. So your interquartile range, which is the range of your middle 50% of the data, is going to equal to 10. Yay! Do we understand how to do this?
Yes.
Awesome. Okay. Now, here's the thing with this. It gets a little bit more complex, but I'll let you figure it out later. That's why you gotta give me like questions. Now there's something called a box and whisker plot. Sometimes it's called box plot. I noticed that in high school, I don't know what it was. I just ignored the teacher when they were talking about this because anything that was, don't ignore me. But let me tell you what the consequence of me ignoring the teacher about this. I just ignored it. I didn't care what box plots were. And even as a math major, I like ignored it. I don't care. So you would ask me in school, like in college, like what was a box plot? I'm like, I don't care. That's how it was. But let me show you what a box plot is. Okay. It arises from
What diplomas do you have?
math. That's it. Math. Math.
What a nerd.
Math. Okay. So let's talk about this. Okay. So when you get a box plot, it looks something like this. All right. And I'll show you how to create one right now. Okay. So you might get something like that. And we would think something like this will be like approximately symmetrical. Okay. Now, if you get something like this, I should do a better job of that. Oh, wait. And the little line in the middle is here. We think that this might look something like this. And that's right, Skew. What do you say, Natalia? Did it look symmetrical? It has a tail. We call that a right skew, sometimes referred to as a positive skew. And now you might get a box plot that does the opposite, where the middle line goes over here. And we might think that something like that looks like that. And this is a left skew. Now, there's a bunch of little details here that I'm not going over. And these are a little bit too loose. And AP stats is a little bit different. We look at even where the whiskers are at. These are the whiskers. Box plot. This is the box. Box and whisker plot. But that's loosely what it is. But the thing is, I haven't talked to you about what this means. So let me show you how to create a box plot. I'm just going to pick up problem here, and we'll do it together, I guess. Well, first I'll do one, and then we can do it together. So I'll just I already picked the problem, but I just don't like it. This problem's fine. So this is page, and I'll scroll that board up. Page 48, number 8, C, and it has 37, 48, 60, 72, and 82. I can't look. It's gonna I have a little hair on there, so blow it away. Okay. So you see those numbers there? I mean, I don't really like this data. You know what? Ignore the page. I'm gonna make more numbers because this is not challenging at all. So there's a 30, there's a 65 here. Let's put it in order. Okay, fine. 25, 90, and 93. So the numbers are in order, right? All right, so here's what I want you to do. I want you first to find the median, the second quartile, basically. Yes. 1, 2, 3, 4, 5, 6, 7, 8. There's 9 numbers. So the middle one is 9 plus 1 is 10 divided by 2 is the 5th number. So 1, 2, 3, 4. It's this guy. So this here is our median. It's also referred to as our second quartile. Good. Now this divides the data into a lower half and an upper half. So we have how many numbers do we have in the lower half? In the upper half? Both of them are even. So the middle two are these two. So you took 30 and you added 37 and you divided by 2 and you got, and that's the first quartile. Be careful. And then you took 90 and you added, or you took 82 and you added 90 and then you divided by 2 and you got, okay, agreed. And could you tell me what the smallest number is?
25.
That's called your minimum. And what's the biggest number? That's max. And what we have done now is we've done something called, and let me pick another color here. I kind of like this one. This is an interesting blue. We've done something called our 5-number summary. So the 5-number summary is basically this. It's a listing of the minimum, the first quartile, the second quartile, which is, by the way, your median, your third quartile, and your max. So that's 25, 93, 33.5, 86, and 60. So I'm making a number line at the bottom there. Okay, and I'm gonna pick a scale. I think it ranges from 25 to 93. So let me make it a little bit longer. And I'm going to change the color of my thingy right now to, I guess I'm gonna go with orange. I've never done orange. So let's start here. 30, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. All right, so we start with 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100 just because. And here's what I do. I go to myself, okay, what's the smallest number? And then, wait, let me pick another color. Give me 1 second. So I'm picking another color. It's going to be red. So here, I put a dot there. 25. What's the biggest number? 93. You could sell, yes. Why not? Yes.
If it was cold, like, if it was cold back then, now.
They want to get abs.
Yeah.
You want to see my abs?
I mean, and I had you last year, we were talking about it.
He showed us right now, they're sure.
I didn't.
I
It's
mean,
through the shirt.
Sorry.
They're good. They're good. They're solid. You want to see them?
No, no, no.
Okay.
You look at it right now. I need to go.
Yeah. All right, guys. Take care. That's pretty good. You guys are creative. Okay, so I put a dot at 25. I put a dot at 25. I put a dot at 93. Some people like to write here the number. All right. And the first quartile is 33.5. So I make a line there like this. I go, bloop. So let's just say this is 33.5. And then 60, I make another line. And at 86, okay, bloop. And then 86, it looks like this. We make another line. And I put 86. And now I make my box. So let me see if I can do it with my ruler. It's not the best box, but it's pretty good. Okay, it's good. Okay, but let me make that line a little bit better. The ruler doesn't let me, of course, because that's life. And here we go. I cross out the 80, but who cares? You guys know what I'm trying to do. Okay, so 80 is here. And then I go whisker and whisker, and there's my box plot. I mean, I could have done a better job, but there you go. That whisker is messed up though. For some reason, I don't want to let it slide. So I'm gonna go ahead and just like make the whisker a little bit better and put the dot here, 93. And there you go, 25. And you're done.
Can I ask you a weird question?
Go ahead.
Who wrote Jimmy and Cosas a joke on your board?
I don't know.
I feel like it might be William Kerr Jr. No, I think it's a girl.
It's a
Can't be
girl.
William because
Who's William?
William.
Good morning.
Yes.
Hi. Did Caitlin Estrada was there this morning?
Yes, she was.
Okay, thank you, because I marked her absent for periods. I just wanted to say.
Okay,
Okay, thank you.
no problem. Oh, no.
Hello.
Kaden's
No,
mother
that
teaches
never
my
happened.
daughter. All right, by the way, if you had to figure out your interquartile range here, could you do it? Yes, so let's do our interquartile range. It's 86 minus 33.5. What does it come out to? What is it? 52.5. And how about the range itself? It's going to be 93 minus 25. That comes out to what? 60 what? Okay. Good. By the way, what's your median again? Yes, this is what we do. Now, let's get to the part that nobody wants to ever learn.
Then why can't you just leave it here?
But once I do this, I'm done with chapter 3 and I
Now
can
we like to take a nap?
torture you guys with work. And this one would be an easy A. You'd be surprised how many people will not get an A today. We are going to take a test on this. It's not next class. Okay, so let's go ahead and do the dreaded standard deviation. And if you end this class, which it could be possible, but I remember the first time I dealt with standard deviation was in college. But then when I in a physics class, we were asked to count the amount of particles that were going through some detector. The detector was counting, and then we were supposed to like do a standard deviation for it. And I was, oh yeah, okay.
I'm like, I don't know where he's writing.
I'm sorry.
Oh, shoot. You just had to start from all the way.
Yeah, I'm sorry. Don't you like my notes? Are my hand is my handwriting that bad?
No, for a guy's handwriting, it's legible.
Oh yes, I'll do rainbow. Let's do rainbow. Okay, so let's use rainbow to at least try to make this section nicer. Okay, so here's what happens. Okay, here's our problem. The measure of spread we've just been doing is not too useful mathematically. It's not. It's like the ones we've done so far, we would use if the distribution was not symmetric. It was skewed. There is a better way. And this way we call a standard deviation. Okay, so the standard deviation. And this is going to take me a good amount of time to just go ahead and go through it. And so that you guys can do maybe the calculation of it. But in order for you to be comfortable, you're going to have to practice. It's not so much, I mean, I know from the standpoint of doing the calculation, it's not hard. It's better to understand the meaning of it. And that takes maybe a little while. So let's start with the calculation. So let's say, and I'm not going to use the book's questions. I'm going to go ahead and just, do it just basic, because a lot of you haven't taken statistics. And I think in this class, how many people have taken statistics in this class? Just 1, 2, 3, 4, 5, 6 people? No, all of you taking statistics? Yeah, okay. Good for you.
I didn't raise my
You
hand.
didn't raise your hand.
That's not everybody in this
Okay, I'm
class.
sorry. Okay, so like half the class is taking it, half the class hasn't. Okay, so let me pick these numbers. All right, I know these are kind of trivial numbers, but if you can do this, the standard deviation with this, then you can do it with others. Okay. So what the standard deviation wants you to do is it wants you to find out the average spread of the data from the mean. What we want to do is we want to find an average spread of the data from the mean. So the first step that we do is we say, hey, find the mean. Find the mean. The mean is just a measure of center, which takes into account each of the numbers. It's superior to the median. Now, there's times where we should use the mean and times where we should use the median, depending on the situation, but we're not talking about that right now. So if you take the mean of this, you know, the mean is the sum of x divided by n, which in this case will be 1 plus 2 plus 3 plus 4 plus 5, all divided by 5. 5 plus 4 is 9. 9 plus 3 is 12. 12 plus 2 is 14 plus 1 is 15 divided by 5. That is 3. Agreed? Now, here's what I want you to pay attention to. I'm going to go ahead and do this in chart form for everybody. So here are my x's. We have 1, we have 2, we have 3, we have 4, and we have 5. Now, if you take x and subtract the mean you just found, this here is called our deviation. So I'm going to try to get some space there. This is our deviation. That's how far I guess you could say how far it is from the mean. The mean may or may not be a number that exists in the data set. You know, because sometimes you have some data and you do the mean and it just gives you some decimal that's not in there, but it's okay. So what's 1 minus 3?
No, 1 minus 3, -2.
-2. And what's 2 minus 3?
-1.
And what's 3 minus 3?
0.
And what's 4 minus 3? And what's 5 minus 3? 2. Okay, so what we're thinking is, think about it. We just got the distance of each of the x's to the mean. So maybe we can add these up and divide by 5, and we will get an average of the spread, of the average of the deviations. Does that make sense? Like maybe like we just got from each number, we got how far away they are from the mean. And if we add up all those deviations and divide it by the total, which will be an average of the deviations, we should get like an average, an idea how spread out the data is from each other, from the mean, on average. So if we add up these deviations, what do you get? What happens when you add up the deviations? That's a problem. And it always happens that way. No matter what you do, it happens that way.
What's the point of the deviation?
Because here's what we do now. In order to rectify this, we can do two things. We can either just ignore the negatives and make them absolute values, or we can square it. In statistics, we square. Now there is one that we do with absolute value, but that's not what I'm interested in today. What we're gonna do is square this. -2 squared is?
No.
4. It's positive. When you square a negative, it comes out positive. Be careful with your calculator. Some of you are just careless and don't realize that. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. This here is called, well, your squares. These are called squares. You should probably say it's square deviations. And then down here, we add them up. This is also called our sum of squares. And we add all these up, we get 4 plus 4 is 8, plus 1 is 9, plus 1 is 10, we get 10. So now we can take our 10 and divide it by 5. We get 2. This here is called our variance. Our variance. In other words, our variance is the sum of our squared deviations, our sum of squares, divided by n. Now, in this book, they don't make a distinction between a population and a sample that I can tell. It's always been that way. So we'll just leave it at that. But the thing is, since we squared, what do we have to do to get rid of the square? We had to take the square root. So if you take the square root of s squared, you get your standard deviation. So s here equals the square root of 2, which is your standard deviation. Now, that means every problem you do, you have to follow this procedure. Now, there's a shortcut to doing this, right? Those of you who took statistics before, do you remember how to do the shortcut to standard deviation or the variance? Do you remember how you guys reacted when I did it and I said it was a shortcut and then you guys got upset at me? It didn't feel like a shortcut.
Then don't teach me that. It's
You-
a longer way to do it.
It's not a,
It's not a long way to do it, it's a lot more easier to do, but the problem is,
That's
fine
why
when you have,
it's
if you have that many numbers, it's fine, but if there's like 100 numbers that you have to do, this is. Okay, so for this number of the
you're welcome.
sample, it's fine to do it this way. But when there's 100 numbers, this has to find the deviation it's hard to do, so the shortcut is shorter, but it's a.
That's a poor, unfortunate haircut.
Okay, so here's what I'm gonna do.
Like I saw when you. Look at it, look at it. Like, go back.
What's wrong with him? What's so funny?
Haircut.
Funny?
Like I just like it's like not a bad length. I just like.
Okay, we're going to do the quote unquote shortcut. So here's what you got to remember. The variance is the sum of our square deviations divided by n. This is our variance. And our standard deviation is merely the square root of our variance. Okay, now there's a shortcut to this. It's not like if you have 5 numbers like we had now, executing a shortcut may or may not work. Like it'll work, you get the right answer, but like it might not make sense to do it. But if you have a lot of numbers, like the shortcut comes in handy, assuming you have a calculator. So let's begin. So what does the sum of x minus x bar squared mean? Well, it means this. So let's say I start here with s squared. All right, is the sum of x minus x squared, x bar squared divided by n. And I were to write what it means. Well, it means take the first number, subtract the mean, square it, plus the second number, subtract the mean, square it, and then add all the way up to the last number, which we just say the nth number.
So if you were to have 100 numbers, you do the 100 times.
Yes. And then all this you remember to divide by n. Correct. because then I have to write the square root. So let's just leave it as variance for now. Okay. So you guys remember from algebra, if you take, and I'll just, I guess I'll make like a side note there. You know, I'll just, yeah, I'll do it in a different color. You remember from algebra that this means this. Give me 1 second. It's my business partner. I'm recording. There we go. So if you take a look at this, all right, if you do x of 1 times x of 1, you get x of 1 squared. And then if you do x of 1 times negative x bar, it's negative x of 1 x bar, right? And if you do it again, that's going to be another x of 1 x a bar, and then it's plus x bar squared. That's what happens when you execute that. And you can like kind of combine these and end up with negative 2x of 1 x bar plus x bar squared, like that. So that's what happens when you expand that. And so back to this. So the second thing here is going to look like this. It's going to look x of 1 squared minus 2x of 1 x bar plus x bar squared plus x of 2 squared minus 2x of 1 x bar plus x bar squared plus dot 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 plus x of n squared minus 2x of n x bar plus x bar squared, all divided by n. Okay, fine. So now, if you take a look at this, you have 3 groups of things happening. You have this guy, we can group them together. This guy, you can group them together. And then this final guy, you can group those together. And let me do that. So basically what you have is you have s squared equals x of 1 squared plus x of 2 squared plus dot 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 x of n squared. Then you have minus 2x of 1 x bar minus 2x of 2 x bar minus dot 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 minus 2x of 9 x bar. And then you have plus x bar squared plus x bar squared plus dot 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 plus x bar squared. And this happens, if there were 10 numbers, it happened 10 times. If there were 50 numbers, it would happen 50 times. But since there's n numbers, then it happens n times. And this divided by n. All this divided by n. Now, here's what happens. If you add up all these numbers, you could just say that the sum of x squared is this. X of 1 squared plus x of 2 squared plus all the way to x of n squared is just add up all the numbers squared. Now, when we look at the second part here, we realize that each one of these share a 2 and an x bar. So I can go ahead and factor out a 2 and an x bar. And then what's left is x of 1 plus x of 2 plus all the way to x of n. Now notice I'm writing plus because I have the negative outside. And finally, there are x bar squared happening n times. So it's just n. And that didn't come out right. It's n times x bar squared, all divided by n. So now the next step, I realize, just to clean this up a little bit, that this has become 2x bar sum of x. Because this here is just add all the x's. And then I'll just rewrite the next part here. Divided by n. Now, let me continue here. If you take a look at this carefully, something should be jumping out at you a little bit. Like, for instance, I can write sum of x squared here, but then I can write that this x bar is sum of x divided by n times sum of x. Look at that. You saw what happened there? What happened was you realize that this here really is the sum of x divided by n. And now that lets you say that this here is sum of x divided by n, but squared. Okay? So, we start simplifying. Yeah.
The shortcut is longer than that.
No, the derivation of the shortcut is longer than the actual way. Me showing you how to get the shortcut is, of course, longer, but once you know the shortcut, what it is, it's much better. Only be careful. All right, so take a look at s squared. S squared is the sum of x squared minus 2 times the sum of x times the sum of x, which will be sum of x squared divided by n, plus n times the sum of x squared divided by n squared, all divided by n. And so now you have that s squared equals the sum of x squared minus 2 sum of x squared divided by n plus, and one of the n's canceled, and you're left with sum of x squared divided by n, all divided by n. And so if you combine like terms, you get the s squared is the sum of x squared minus the sum of x squared divided by n, but all this divided by n. Now that is the shortcut. This book doesn't like to express it in that way. It has a slightly different way. Like if you continue doing this, you'll realize that this is really sum of x squared divided by n minus the sum of x but squared divided by n squared. And then this becomes the sum of x squared divided by n minus the sum of x divided by n but squared, which in turn becomes the way they like it. Well, and so now this becomes finally that s squared equals the sum of x squared divided by n minus x bar squared. And this is the way the book wants you to do the shortcut to the variance. So this is the shortcut. And you're like, it's not a shortcut. I'm like, yes, it is. But you got it. So watch, let me show you what I mean. Let me show you what I mean. So this is a shortcut, and obviously s still equals the square root of s squared. So whatever you get here, you square root it to get your standard deviation. So let's start with a problem we were doing earlier. Well, I guess, I don't know if you guys are getting your money's worth, but I'll keep on trying. Well, your taxpayers' worth. Taxpayers' worth.
It's like you don't pay taxes yet.
Well, your parents do. Your parents do.
For the internship.
Here's 1, 2, 3, 4, and 5. Here's all you gotta do. Okay? We're gonna figure out s squared. Okay? How many numbers are there? 5. What's the mean? The mean is 5 plus 4 is 9. 9 plus 3, 12 plus 2, that's 15. Divided by 3, it's 5. I mean 3. 3. 15 divided by 5 is 3. And then what is the sum? This is the worst one, sum of x squared. Well, let's see. What's 1 squared? Plus 2 squared. Plus 3 squared. Plus 4 squared. plus 5 squared. So we're gonna do that. So that's 25 plus 16 is what? Okay, 5 squared is 25 plus 4 squared. That's 25 plus 16, right? What's that? Is it 31 or 41? 41. 41 plus 9. 50. 50 plus 4, 54, so it comes out to 55. So if you add all these numbers up, squared, it's 55. And now you just put it in the formula. You go S squared, your variance, equals 55 divided by 5 minus 3 squared. All right, so what's 55 divided by 5? 11. And what's 11? And I just put a 9 up there. What the hell? Squared. And minus 9. What's 11 minus 9? 2. And then isn't that what we got before? Yeah, come up here. What was that squared up here? You look at your notes.
Oh, so look at all my notes. Look at what notes. Those are
2.
my notes.
So notice that it's completely different, but it's the same. You're saying, well, what's the shortcut? Well, here's the thing.
No
If-
short. Look at all that work.
Yeah, but look. What I'm trying to say is there's an advantage to using the shortcut. All you got to remember is the bubble. The advantage is, let's say I have 15 numbers. All right. All of a sudden, the shortcut is a godsend. Okay. Yeah, like even 10 numbers, it's an advantage. Like you'll start doing it with a shortcut, like with a regular way that you're comfortable with, and I'll start with a shortcut. I'll be done like 10 minutes ahead of you. You'll still be like writing things down in calculator, and it's horrible. Okay, so that I think finishes this up. What do you mean your brain's done? But you're still talking.
Mentally.
All right, there's more formulas, but I'm gonna leave it at that for today. So let me, the quiz, yes. So there we go, and
It's just on mean, medium, and mode, right? It's like nothing else.
And the, wait, oh, the test.
That's just